Hello and welcome to our latest LinkedIn Live session leading up to the Sustainable Packaging Summit 2024. My name is Elisabeth Skoda. I'm the editor-at-large here at Packaging Europe. The Sustainable Packaging Summit aims to create an environment dedicated to making packaging fit for purpose in a rapidly changing world through honest dialogue on challenges, promoting strategic alignment, revealing new approaches that work, and sharing the biggest opportunities in innovation. So on the 12th and 13th of November 2024, we will welcome leaders of the international packaging value chain, brands, NGOs, recyclers and regulators, with a shared mission to accelerate sustainable transformation in packaged goods. And I'll share a link to the event in the chat box where you can check out more information and book your tickets. So now to today's LinkedIn Live session. And the supply chain has been facing numerous challenges and innovations. Innovation is key to addressing these. And today, I'm very pleased to have Elizabeth Starb with me, who is Rigid Packaging Sustainability Manager and HB Fuller. And we'll also be joined by Charles Smith, who is founder and CEO at Interpack. And they will discuss supply chain challenges around corrugated board and how cold corrugation, a technology developed by these two companies, can help address these challenges. I should also point out there'll be an opportunity to answer audience questions at the end. So please make sure you put any questions for Elizabeth and Charles in the LinkedIn chat, and I'll ask them at the end of the session. So welcome Elizabeth and Charles. I'm really looking forward to finding out more about this topic, and I'm looking forward to a really interesting discussion. Let's head straight into our conversation and start by discussing the issues that sheet converters faced during the pandemic and how a new process and technology can alleviate this. And I want to start by asking you, how did the COVID-19 pandemic specifically affect the supply chains in the packaging industry? And what are the key lessons companies have learned about supply chain vulnerabilities from these disruptions?
Hi, good afternoon. It's great to be here this afternoon with you. And if we think back to the pandemic, it already seems like a long, long time ago, but there were really some tough challenges in the supply chain for the packaging industry overall. I think we were all very used to a well-oiled machine when it comes to supply chains and things really working fairly smoothly. But if we think back to that time between 2020 and 2022, that was a really tough period for supply chains globally. There were many shortages, industry needed production permissions, there were closed ports and the like. So it really had a profound effect on the entire packaging industry, and particularly servicing fast-moving consumer goods and food and beverage in particular, because of course we all needed to eat and drink during the pandemic as well. So planning stability really went out of the window. Many companies really had to go by sight in terms of producing whatever they were able to based on the raw materials that they had in their warehouses at that time. So there were many delays, there were many split shipments, partial shipments. And I think part of the lessons there really were that now there's been considerable reorganization in the supply chains, nearshoring, etc. But the time period there was really tough for suppliers. And Charles has a more detailed view on how that affected the sheet converters.
Yeah, thanks, Elizabeth. That's quite correct. In particular, sheet converters faced a severe issue during the pandemic, trying to purchase corrugated board from their suppliers. Often what was ordered was definitely not what was delivered. That was a major problem, and often also subject to almost certainly weeks of delay, if not months in some instances. And sheet converters, who are down the scale of supply, really had nowhere to turn and had to make do with whatever they were sent. Integrated sheet feeders, those with their own sheet conversion equipment, had to prioritize keeping their own factories running during that pandemic, and often that was at the expense of delivering corrugated board to their customers. And as a result of that, many sheet converters faced severe challenges as their conversion equipment just simply stood still. Without corrugated board, they were simply starved of the vital oxygen that keeps their business running.
Yeah, that sounds really tricky. And I understand that these challenging circumstances in the corrugated industry, in particular for small and medium sheet converters who are entirely dependent on sheet feeders, sparked an idea with you, Charles, didn't it?
Yes, indeed, it did. So the idea of moving production of corrugated board to the point of need, so that's actually at the sheet converter, is something that Interpack has been working on for a while. But the pandemic really accelerated that whole idea with us. You only have to talk to any sheet converter to know that they are desperate not to repeat the experience of that supply chain collapse back in the pandemic. So there's clearly a need for some fresh thinking here to reduce the dependency of sheet converters and their board suppliers. And in my view, that means that the time for cold corrugating has certainly come. With a low capital cost, it allows sheet converters to produce their own corrugated board in their own factory exactly when they want it, no longer dependent on a supply chain above them.
Great. And could you explain the concept of cold corrugation and how it differs from traditional methods a bit more? We have it picked up here as well, which I'll bring up now.
Yes. So you can see a picture of our machine here, actually, but instead of using steam, this is the key, using water and starch, our machine corrugates the board at room temperature. It sounds simple, but removing the steam and water from the process is transformative. So firstly, it allows us to shrink the corrugator down from typically well over 100 meters long and 2 stories high to just 29 meters long. And this means it easily fits into a sheet converter's factory. And that's a key point. Plus, because there's no steam generating plant required. So it's low power. And because it's small and lightweight, there's no need for foundations. It just bolts straight to the floor. So with no steam, no water, it becomes a simple 2-man operation and greatly demystifies the smoke and mirrors that surround traditional corrugated cardboard production process. It's compact in nature and simple in operation, and it allows our chief goal to be achieved, which is moving production to the point of need.
Sounds great. And I wanted to ask you both, how did the partnership between Interpack and HP Fuller facilitate the development of this cold corrugated machine? And how does the HP Fuller adhesive contribute to this new cold corrugation machine as well?
Well, the partnership between Interpack and HP Fuller really came about as Interpack were looking for a specialized adhesive for this new process. And they had tested a couple of off-the-shelf products in the market when they came to us and said, well, we really need something that is customized to this very short and fast process, because that then means that there's a very short pressing unit to give the adhesive a very short window to anchor well to the paper. And so that's really then a challenge that our technical team were able to tackle using a water-based adhesive with traditional technology that then permits the board to be created and made very quickly, but the residual humidity needs to be monitored very carefully. Because there's no drying tunnel, there's no steam, as Charles was describing. So you save all that energy, but then of course the adhesive needs to be carefully dialed into those requirements. So with the HP Fuller technical team and the development team, this customized adhesive was developed in order to fulfill these very unique requirements. And so the openness from Interpack and the machine builder and then the technical team of HP Fuller really coming together and figuring out what the best possible solution will be here, what the requirements are, and how the adhesive can be dialed in. Really that openness and that sense of collaboration really came to the forefront to make an adhesive that's truly a customized solution for this new process.
That makes sense, yes. And obviously users of corrugated boards, especially in the e-commerce area, are looking more carefully at the environmental impact of the packaging materials they're using. And could you explain to our audience how cold corrugation differs from the traditional corrugation process, Charles?
Yes, it differs greatly, and all the numbers move very swiftly in the right direction. I'll just quickly talk you through it. So, but commercially, can I just say that the first thing is sheet converters will save about 30% on the cost of their board. In effect, what they're doing is by making their own corrugated board on our machine, they're taking the profits that would be made by sheet converters and translating that into savings on their board costs. But moving on to the benefits in terms of the environmental impact, obviously eliminating steam and water makes the process far cleaner and far more efficient. So the board that comes off our machine, it uses 41% less energy per tonne of board compared to conventional corrugator. And that's a huge saving. I'll come onto that a bit more later. But also we use 98% less water and 80% lower transport costs compared to existing production methods. And overall, if you translate those savings into a CO2 reduction, Interpak's process delivers 61% reduction in greenhouse gas over conventional board. Now that's a massive drop for industry that's trying really hard with existing assets to achieve a reduction of just even a few percentage points, 61% in one hit. And also, it's not just the industry that benefits from it, but it's a huge win for the end users who need to improve their sustainability of their packaging. It's a hot subject at the moment, and a reduction of 61% in CO2 emissions on their packaging is a real game changer. Just quickly to say, the figures I quoted are from an independent assessment that was carried out by WSP a month ago, and they used the FEFCO report on 470 corrugated board manufacturers across Europe. So it's a really good, strong set of figures supported by data. So that gives you the headline figures on the environmental impact.
Yes, definitely very impressive figures there. And I wanted to ask what specific advantages can be derived from producing board with cold corrugation in contrast to traditional steam production?
Yeah, good question. So our first production machine is now installed with our first customer. They're a sheet converter company in Frankfurt, and they're running many different trials of different paper qualities. And we can clearly see that the production process, because there's no steam, there's no water, is very gentle on the paper. And as a result of that, the board doesn't display the typical washboarding or warp effects that are seen with traditional corrugated board supplies. And this means that the surface is, in essence, completely flat, and hence it's highly suitable for high quality print, and particularly suitable for digital print. It has a superb finish, and this really plays to high quality print.
And I just wanted to add to that really this very flat finish has been made possible by the adhesive really being dialed into the parameters of the machine, making sure that there's good runnability and that the residual humidity in particular is absolutely optimized to keep the sheets as flat as possible, and using good paper anchorage so that then also the overall board dimension stability is given so that you have these very high quality boards, very flat, that are then suitable for digital print.
Yeah, absolutely key point.
And what are the current R&D efforts focused on developing bio-based adhesives, and how will they enhance the eco-friendliness of the cold corrugation process?
Well, currently we are using a standard PVA for this product because we really wanted to make sure that we can dial in the process and make the machine work as best as possible and really get the benefits from the process of this new equipment. And then in the second step, we have now started the development of an adhesive based on renewable raw materials that, of course, will then enhance the eco-friendliness of the cold corrugation process. So our R&D colleagues and sourcing colleagues continuously work with raw material suppliers in order to understand what type of options we have with renewable raw materials. And then we have a dedicated team that looks at the carbon footprint of our adhesives to understand the impact that they then have on our customers' Scope 3 measurements. As we're getting more and more questions from brands, from packaging producers, they want to understand their Scope 3. So that's also why Charles and the Interpack team have gone to great lengths to measure the carbon footprint and impact of the cold corrugation versus the industry, as Charles was describing earlier with the FEFCO data and comparing to the FEFCO data that's available, so that we can really differentiate this new cold corrugation process versus the traditional steam production process.
Thank you, Elizabeth. And I was wondering, could you share some case studies or testimonials that highlight the success of the cold corrugation machine and HB Fuller adhesives in real-world applications?
Yes. I mean, it's important to recognise that Interpack and cold corrugation, we're on a journey. So we have got our first production machine. You can see it in the picture behind me, actually, installed in a sheet converter in Germany, as I mentioned. And they are able to run quite a wide variety of different paper types. Certainly, they can run high quality coated papers, and they're very interested in the ability to run papers with barrier coatings because there's no heat in our process that would damage barrier coatings, unlike a conventional corrugator. So it has a lot of potential to run quite a variety of different grades of board. Digital printers, just getting back to that point about warp, we've been talking to an American company recently, and they've got a big digital printing installation, and the board that they buy in, which has warp, it's twisted quite often, damages their print heads. And last year they had to replace 13 sets of print heads, $60,000 a set. So this is the real world cost of warped board. And the other aspect we've seen is that the company in Germany can change their board grades from one board grade to another very quickly and easily in a matter of minutes, in fact. And this allows them to run many different board grades during just one shift. And in turn, this allows them to offer their customers, the end user, a much wider range of products with, of course, faster delivery. And there's a few other benefits that are slowly coming to light now. So storing denser paper reels, corrugated board is 50% air, by the way, rather than storing corrugated board, takes up considerably less warehouse space. So that's something we're seeing coming through from our German customer. And they are looking at producing corrugated board in the morning, printing it, and then shipping it out to their end user, the customer, same day. So a much improved and premium service that's available because they're making their own board.
And I just wanted to add with that, as Charles was illustrating, many different types of paper can be used for the corrugated, and all the tests that have been run to date with the first machine here in Germany at the converter and in Frankfurt have all been done with the same adhesive. So while you're changing the paper, in order to be able to make different grades of corrugated, the adhesive stays the same. So that's a tremendous advantage in terms of thinking about machine stoppages, how fast you can switch from one to the other in terms of cleaning time, etc. So really having the customer and the use case in mind, this adhesive was customized to the application.
Yes, that's correct. So the different board grades all run on the same adhesive, and again, that's absolutely key, and that's down to Fuller's skills in producing a bespoke solution for us.
Great, thank you. And I wanted to ask you both about the long-term vision for sustaining efficiency and sustainability in the corrugated board industry.
Well, I am biased, but clearly I don't think it takes a brain of Britain to work out that moving production to the point of need is absolutely the key to lowering the CO2 of corrugated packaging. That is the fundamental, because it removes transport, it removes heat, it removes energy, it removes CO2. But it also gives sheet converters increased control of their own factory, their own destination. It gives superior quality, and it gives that nice warm feeling of independence from any future supply chain challenges. And cold corrugating, developed between Interpack and Fuller, it delivers all of these benefits, and it shows the power of collaboration with partners such as H.B. Fuller, key to developing new technology like this. Thank you.
And I just wanted to add into that as adhesives are generally a very small component of the final product, in order to have disruptive innovation like the cold corrugation process, collaboration and trust are absolutely key. And we have many technical specialists at H.B. Fuller that have been trained in design thinking innovation, specifically to be able to think through that entire process, how it affects our customers, how it works through the machine, how it works through the entire supply chain, in order to understand all the parameters of the product and specifically of the adhesive, what it needs to fulfill in order to then technically be able to develop and customize that adhesive for that specific application. So I have to say, I couldn't be more pleased with the results that H.B. Fuller and Interpack have been able to achieve together to really get this cold corrugation process dialed into a T and get the results when we see the various different types of corrugated board qualities that the first customer is now able to produce. So I really think this is the beginning of a fantastic journey together, and really shows the power of collaboration, that we can then really achieve new breakthrough solutions, sustainable solutions that the industry so desperately needs.
Yeah, I'd say it's no exaggeration that Interpack couldn't have got this machine into the market without a glue supplier like Fuller, who's prepared to be flexible, helpful. These are absolute key requirements and a rarity.
Yes, it's always great to hear successful collaboration stories that that boost sustainability and efficiency. So yeah, it's been really great to hear about this and a very exciting technology. So yeah, that brings us to the end of our discussion today. Elizabeth and Charles, thank you very much. And yeah, now it's time to see if there are any questions from the audience. And obviously, if you're watching this on demand, feel free to reach out later on as well to Elizabeth and Charles. I'll put up a slide later to see so that you can see how to contact them. But we already had a couple of questions come in a little bit earlier. And somebody's wanting to know a bit more about the adhesive, and they're asking, is this a sustainable adhesive, and could you elaborate on this? And I think we have a slide here that's quite suitable for this as well, so I'll bring that up. That might sort of also answer a few more questions. But yes, back to the question about the adhesive and whether it's sustainable.
Thank you, Elizabeth. Well, the adhesive today is a traditional technology, a PVA-based, water-based adhesive that is traditionally used in packaging maker applications. And again, really working with Interpack to dial in the processability and making sure that the board quality is what is needed and desired. We worked with traditional technology and really looked to perfect that as best as possible to make the process possible. So as mentioned, our technical team is now working with alternative renewable raw materials in order to have the next generation adhesive that is then based on renewable raw materials and takes down the carbon footprint of the adhesive overall, and therefore then the carbon footprint of the final product.
Yeah, I'd just quickly like to add that the usually boxes are sealed at the ends using PVA glue. That's been happening for years. So it's already a well-established product in packaging. And our application uses less than 7 grams per square meter. So the amount of PVA glue is absolutely minimal.
Great, that makes sense. And somebody else has asked us, what kind of corrugated board grades can this machine do particularly well?
Well, I'd like to say it's a jack of all trades. There isn't anything that we've been asked to try that we haven't been able to run. And we've done a lot of tests for quite some fairly large companies on very weird board grades, trying to catch us out. So far, it's run everything. What is its strongest suit? Well, from a commercial point of view, sheep feeders make the most profit from specialized board grades. So that's the high quality coated white board grades for high quality packaging. That's where the money really is. So if you make your own high quality board, you save even more money than you would do if you were just making brown board. So I would say, short answer, make specialized high quality boxes.
Sounds like a good tip, yes. So that's all the questions we've had for the moment. You've obviously explained everything very well, but I will now move to the next slide where you have the contact details of Elizabeth and Charles. So obviously, if you have any other questions or if you're watching this on demand and you want to reach out, feel free to contact them on the email addresses provided here, or you can also put the questions still underneath in the LinkedIn chat, and I'm sure somebody will come have a look and get back to you. So yeah, that just leaves me again to thank you, Elizabeth and Charles, for sharing your insights today. It's a really interesting discussion. I feel like I've learned something as well about cold corrugation. And yeah, if you'd like to see more of HB Fuller, they'll be attending, exhibiting and speaking at the Sustainable Packaging Summit in Amsterdam, which, as mentioned at the beginning, takes place on November 12th and 13th this year in Amsterdam. And yeah, we look forward to seeing many of you there. So yeah, thanks again, Charles and Elizabeth, and goodbye.
Thanks. Bye-bye.
Thank you.